Okay, so last semester we talked about a few examples like this. In fact, we had a couple in a packet that we did. When we have a circle and you take any two chords of that circle, pretend that looks round. Take any two chords of that circle that intersect. The chords are cut into pieces in such a way that the products of the pieces within a chord are the same for both of them. For example, let's say that this is 3 inches, this piece here is 4 inches, and this one here is 12 inches. If I label that one X, we can find that length, X, because the products of the pieces within a chord has to be a constant when they intersect. What does that mean? Well, that means here 3 times 12 is the product for the pieces of that chord. That has to equal the product of the pieces for this other chord, which would be 4 times X. And we can solve that. 3 times 12 is 36. How do we find X? Divide by 4. So X has to be 9 inches. This one looks different, but the same rules apply. You take this and extend it all the way down to complete that chord. Now, since this is a right angle, anytime we have a line intersecting a chord at a right angle, and we're assuming that's centered because of the way that's set up, that ends up, if we extend it, it ends up going through the center of the circle. In other words, it is a diameter of the circle. How do I find this length here? Anybody? Okay, perfect. That 60 gets split in half into 30 and 30. If I call this dimension here, I'm going to call it Y for now. That looks like an X. It's just the center of my circle. I know that 30 times 30, that's the pieces of that chord, has to equal 15 times Y. So then I do 30 times 30 is 900 equals 15Y. And then divide by 15, Y equals 60, which means the diameter is what? 60 plus 15 makes it all the way across. That would be 75 inches. So my radius, 37.5, 37 and a half inches. Perfect. So now I want you guys to try to find if this is 40 inches across here, 8 inches high there. Find the radius of that circle. So walk me through it. How do I...
40 up.
Okay.
20 inside. Just because we can.
Because we can, okay.
The rest of that line, 8 inches.
Okay.
Now we're doing, we're multiplying 20 and 20 to get 400. That's going to equal 8 times up.
Okay.
By side 8 times by itself. And 50 on the opposing side.
Okay.
That's all our diameter.
That's not our diameter. It's that piece, right? So the diameter is, there we go. So radius of 29. Perfect. Well, then let's take it to the next step. You might be wondering, why am I reviewing something that seems kind of simple like that? Well, because you know me, I'm going to make it worse. Of course. That's what I'm here for. With friends like me, you better start looking for better friends.
Friends like you, I just make better life decisions.
That's a good possibility, yes. It's not going to help your grade, Cody. Find the area of the yellow portion. You would start out with what we just did, and then you're going to have to use some trig from there. I'll let you guys get started, and then we'll give you some hints. So when you look at this, of course, you start out by finding the radius. Does anybody have the radius yet?
Yeah, it'd be 9. Oh, it'd be 45.
45. So we have the radius. From there, how would we go about finding that area? Well, we need a couple of things. I'm going to draw this in here. That makes a right triangle there as well. If we knew this angle all the way across here, we could find the area of that whole sector, and then find the area of this triangle and subtract it out. So I'm going to actually just look at one of these triangles for right now. So that's a right triangle. We know this is 40 inches, half of the 80.
Did anyone get 45 on this?
No? Okay. So 45 is not correct. 85 is the radius?
Yeah.
Okay. I tried to trust you, Cody.
I mean, yeah. Whatever.
We can double check it. 40 times 40 equals 10x. Ends up, you're okay then. Equals, x is 160. Plus 10 to give it a diameter of 170. Gives you a radius of 85. So the 85 is correct. So we have 40 there. This is going to be 85 inches. This side here is 75 inches. Anybody know where that came from? You got it. This has to be 85 across there minus the 10. So obviously I'm not drawing the scale here right now, but that's okay. You guys can deal with that. This angle right here, if I found that, I could just double it to get this one here that I'm looking for. I have all three sides, so I can pretty much use any of them. I'm going to use the 40 and the 85 because according to this angle here, 40 would be opposite, and the 85 is, of course, the hypotenuse, no matter what angle I'm looking at. Opposite and hypotenuse make sine. Sine of an angle is opposite over hypotenuse. I've said this a few times before. I'll repeat it again. I almost always write down the definition of the trig function once I pick it out. It helps me put the numbers in, keeps me from making silly mistakes. It's so tempting because you think it saves you some time to just grab the calculator and start punching in numbers. But even I struggle to keep things straight in my head as to what order they have to go in with this stuff. I mean, having something jotted down on paper saves a lot of mistakes. So anyway, what we're looking for here is the angle. The opposite side is 40, the hypotenuse is 85. So since we're looking for an angle, this is an inverse sine. So that angle is the inverse sine of 40 divided by 85. What did you guys get? Did anybody get that far? 28? 2807. Perfect. So it's 28.07, which makes this angle here, the whole one, 56.14 degrees. So now I know the central angle for my sector. I can find the area of the sector. I do that by finding the area of the whole circle. So pi times radius squared. And then multiplying by that central angle, 56.14 over 360. So pi times radius squared times 56.14 over 360. 3537.83. And since that was in inches, this is in square inches right now. That is the area of the whole sector. We only want the yellow portion. So how do we get just the yellow portion? Yeah, we got to subtract out the triangle. That triangle there, we happen to know way more about it than what we think. We know, what's that?
You just find the area
of 1 and multiply by 2. Or, in this case, we actually have, this is 80 inches across here. And we have that this height is 75 inches, right? So the area of that's just going to be 80 times 75 divided by 2. Right?
Yeah.
Otherwise known as 3,000 square inches. Correct?
Yeah, because you make a square out of it.
Yeah.
Square.
Yep, that's basically it. So then we just subtract this minus this. 537.83 square inches is the area of, that's what we call a segment. That's the area of the segment. So I'm going to have you guys try one now again. See if you can get this one on your own. What's that? Yeah, what the heck. Find the area of that segment. So, step 1, what's the radius? 48.75. Does everybody concur? Cool. No, you don't. You're outvoted. So that makes this 18.75 here. What'd you get for an angle in here for this whole sector angle? 45.24. Does anybody else concur? The whole angle.
I got 134.76.
Okay, let's do some looking here. So if this is 48.75 and this is 45, this angle here would be the inverse. Well, let's do this. That's the sine. So the sine of that angle, opposite over hypotenuse. So sine of that angle is 45 over 48.75. So the angle is the inverse sine of 45 over 48.75. Close it up, and we get 67.38 degrees is the half angle times 2. So we're getting 134.76. Okay. Gotcha. You did an inverse tangent, didn't you? Okay. So what do we do from there? Area of sector. So what do we start out with? Pi, okay. So times 48.75 squared. Giving us what? 0.85 inches squared, right? Then what? Area of the triangles. Okay. 90 times 18.75 divided by 2 gives us 843.75 square inches, which means we got perfect. 1951.10 square inches. 1951? Okay. So we're getting that area down. Now remember, last semester when we talked about volumes, how we defined a volume to be an area, or the area of a base, times a height. And I told you, most of the shapes we have their own specific volume formula we could have used, like the area of a box is length times width times height. But by defining it as the area of a base times the height, it freed us up to be able to find the volume of pretty much anything that was a regular shape, that had a base that was able to move through the whole object, that could pass through the whole solid. For example, if we had a weird shape like this, that was our base. I'd put some dimensions on it. And we use that to make a solid. Like this. Let's say that this is 30 millimeters. We could find the volume of that object without having to use any really fancy formulas or anything. All we had to do is find the area of this base. Remember we said even the base implies bottom, but it isn't necessarily on bottom. The base is the shape or the side that the whole solid is based off of. In this case, we could take this shape here and we could slide it through the whole object. That's why it's called the base. Because if we slice that object at any point, we're going to get that same shape. So to find the area of that base, we have some options. In this case, what I would do is this. I would extend it out to make a full rectangle. That full rectangle would be 8 by 16, which would be 128 millimeters squared. And then subtract out that missing triangle. What are the dimensions on that triangle? What's this dimension here? 8, just the 16 minus 8. How about over here? 6, just 10 minus 4. So that triangle is 8 minus 6 divided by 2, or 24 millimeters squared. Giving us the area of that base. 128 minus 24 is 104 millimeters squared. So then the volume of this solid can be found by simply taking that 104 millimeters squared times the 30 here becomes our height. Even though it's not up and down, it's still the height. It's the distance from one base to the next, to the other base. So times 30 millimeters. 104 times 30 gives us, what's that? 2,120. There we go. And that is now millimeters squared times millimeters is millimeters cubed. It's now volume. Yes, sir. Where at? That should be 10 times 16, isn't it? Thank you. So yeah, 16 times 10, not 8 times 16. Should be 10 times 16. You're right. 160. So let me start that over here. Well, 24 is right. Apparently it's not my day to calculate in my head. Or write down numbers from one spot to the next. So anyway, yeah, so 10 times 16 makes that 160. Minus 24 makes this 136. John gets his gold star for the day. So this is 136 times 30. 4,080 cubic millimeters. Make more sense? Anyway, the major point is that's the reason why I defined volume as area of a base times the height. So now, if you can imagine taking that and combining it with what we were talking about 10 minutes ago, we can now look at taking an object like this. And let's say that this is 60 millimeters across here. This is 15 millimeters high. And this is 200 millimeters long. Find its volume. Remember, picture that as a whole circle. use that to find the area of this segment, just like we were a few minutes ago. Once you have the area, it's just area times that length. So let's see what you guys come up with there. So anybody get an area for that piece yet?
Working on it.
How about a radius? 37.5 millimeters is our radius. Okay. Angle in here? 106.26. Sound reasonable? Okay. 106.26 degrees. Sector area. 0.01. Okay. So in the triangle area is going to be what? 675? Exactly. We subtract to get 629.01. Is the area of our segment. You guys concur? So then what? How do we find the volume? You got it. 629.01 millimeters squared times 200 millimeters of length, which will give us what, 100? Is it 12,000 or 125,000? 125,000 millimeters cubed. Perfect. There's our volume. Better than sharp stick in the eye? No? We've reached the point finally. Okay. I get to go home tonight and sharpen my sticks. Not anymore, unfortunately. That kind of went out in feudal times. But if I had lived a few hundred years ago, I probably would have been good at that. You're right. Oh, what do I go here? So now, for this piece here, what I want to know, what is the volume of the material removed? In other words, if this started out as a metal block, to make this circular channel, how much material had to be, and basically you're finding the volume of the shape we just found, it's just different dimensions. False. So anybody got the radius of the circle yet? What's that? 30 is my radius. Anybody have the angle here yet? 106.26 again? Anybody have the area of the sector? 34.57 millimeters squared. Area of the triangle? 432. So we subtract. Get 402.57 is the area. Millimeters squared is the area of the segment. So to get the volume, we simply, you got it. what, 1261.71, something like that? Or, I got my desk point in the wrong spot. 12,617.1 millimeters cubed. What do y'all think? Not as bad as it looks, is it? Well, I got another worksheet to hand out for you guys to work on for tomorrow.